Okay, I'm going to start this question by writing an unbalanced equation, and I'm going to show you that even without a balanced equation, we can still solve the problem. So this will save us some time in the exam. Now, in this case, we have a ClXOY, which is the compound which we need to find out our empirical formula. After reacting with hydrogen, you will know that it will give you HCl and H2O. Can you see that, like question 5, all the Cl from here, all the Cl from here in the product is going to come from here. All the oxygen in water is going to come from here. So we can determine the number of moles of HCl first. Okay, so after doing this step, you should get this number of moles of HCl, and you do it similarly for water, you will get 0.0224 moles. Now, why are we finding out the number of moles of HCl and H2O? Because after determining the number of moles of HCl, we can therefore then determine the number of moles of Cl, because we have a 1:1 ratio between the compound and its constituent atoms over here. Similarly for water, okay, 1 mole of water is going to give you 1 mole of oxygen. Yeah? And since we know that all the Cl comes from ClXOY and all the oxygen comes from ClXOY, we can therefore determine the simplest ratio of the number of moles of Cl is to oxygen in the compound, the empirical formula of the compound. So the simplest ratio, we got to divide the mole by the smaller of the two. So 0.00638 over 0.00638 is to 0.0224 over 0.00638. And you get a value of 1:3.5. Okay, which you multiply by 2, you get 2:7. So this is the simplest ratio of the number of moles of Cl is to oxygen in a compound. And since this is the simplest ratio, therefore it is also the empirical formula, which is gives you D. Oh, this is question 7 is really a trial and error question. But let me just balance the equation for you. Okay, so CH3, CO2CH3 plus O2 is going to give you CO2 and water. Okay, just a simple practice over here. So the first thing that we need to balance is the number of carbons. So we have 3 carbons on the reactant side. So we put a 3 here. Next, the one we're going to balance is hydrogen. Okay, so we have 3 hydrogen here, 3 hydrogen here, so it's 6. So I have 2 here, so I need a 3. Yeah. So on this side, I have another 2 oxygen. I have another 2 oxygen. On this side, I have 6 oxygen. I have 3 oxygen. So in total, I need to have 9 oxygen here. Okay. So 9 minus 2, because of the 2 here, so because of this 2, I will take 9 minus 2 equals to 7, right? I need to have 7 oxygen on this side, 7O. I have 2 here already, so I need to have a 7 over 2 just to balance up everything, okay? So this is the way to balance this equation, and I think most of you got it right. You look at this question 8, the first options that you should see would be this, okay? Because these are the easiest to determine. As long as we sense that the oxidation number of vanadium has changed, we know it's going to be either an oxidizing agent or reducing agent. So over here, we have a vanadium 5, so we know the vanadium here is a +5. Over here, we're not too sure, it's very difficult to see, okay? But we know that SO4 has a 2 minus over here. So therefore, this whole thing must have a 2 plus. Yeah, 2 plus. But since we have 2 of them, so therefore we know that VO2 has a charge of plus. And we can also very quickly see that the V here actually has an oxidation number of plus 5, because plus 5 plus 2 of oxygens minus 2 will give you plus 1, yeah, which matches the charge of VO2 plus. Okay, so both before and after, the vanadium is not experiencing a change in oxidation number. So immediately we got to cross out it is a reducing oxidizing agent. Yeah. Okay, so since we have a dilute sulfuric acid over here, this is an oxide. So if you can recall your acid-base reaction, this is actually an oxide-acid reaction. And metal oxide are basic. So vanadium in this case is acting like a base. That's it for question 8. Well, in question 9, we have the same amount of charge flowing through two electrolysis experiments, and it was found that 16.4 grams of zinc and 5.1 grams of vanadium were deposited by this same amount of charge, and we are asked to determine the amount of charge of vanadium ion. So just you got to just write out a simple equation to represent the process. So in the zinc case, is zinc 2 plus getting reduced by 2 electrons to give you zinc metal. In the vanadium metal, we are not sure of the charge on vanadium, so we're going to give it a charge of X plus. So X plus, Vx plus, you need X moles of electron to give you the vanadium metal. Now, we know that we have 16.4 grams of zinc. We also know the molar mass of zinc, so we can determine the number of moles of zinc over here. Yeah, the number of moles of zinc over here. Okay, next we determine the number of moles of electrons that we need. So this is a 2:1 ratio. Okay, so we need 2 times 16.4 over 65.4 moles of electrons. Now this is very important because we know that electrons carry charge, and this number of moles of electron is going to be the same over here. So I will write down 2 times 16.4 over 65.4 here. Yeah. And we also know that we have 5.1 grams of vanadium, which we can also find the moles. So 5.1 over 50.9 moles. Yeah. And we can determine the mole ratio. Yeah, so this is an X here, this is a V here. So E minus over V is equals to X over 1. Yeah, and this is equals to 2 times 16.4 over 65.4 over 5.1 over 50.9. Okay, and since there is only one unknown, which is X, you can solve the equation and you get X to be 5. Okay, and therefore the answer is D. We have a rather unusual case of electrolysis over here. We have a piece of litmus paper soaked in saturated potassium chloride solution. The keyword here is saturated. Yeah, you got to realize it's saturated. So the concentration effect will definitely come in. Okay, so we have the positive electrode over here. So therefore we have Cl minus and OH minus migrating to the positive electrode, and we have the H plus and K plus migrating to the negative end of the electrode. So immediately you know that A is true. Yeah, it's true. So we are looking for a false statement. So this is true. So A is immediately out. Okay, so let us look at which of the ions will get this charge. So Cl minus and OH minus, which one will get this charge? You know this is saturated Cl minus, yeah, saturated KCl. So you know that because of the concentration effect, the Cl minus is going to come out to become Cl2. Yeah, and Cl2 is bleach, so it is going to bleach the litmus paper. So the part of the litmus paper near the positive electrode will become bleach. Yeah, so this is again true. This is true statement. Yeah, this is out. So H plus and K plus, so which one will get discharged? So I hope you can see that this is the H plus, they will become H2. Yeah. So with a decrease in H plus concentration at the negative electrode, there will be relatively more and more OH minus, which will upset the pH balance. So over there at the negative electrode, it will turn blue. Yeah, it will turn blue. Yeah, it's true. So again, C is the wrong answer. Then it is only answer B, yeah, which is false, because there's really nothing at the negative electrode for things to react, which will result in a decrease in the size of the negative electrode. Yeah, so B is false, therefore it is the correct answer.